Okay, in this video, we are going to talk about the different types of addition and subtraction word problems. So there are 4 types of addition and subtraction word problems. We're going to go through each one and give examples of each one. So the first kind is a join action problem. And this is a addition, example of an addition problem. So a joint action problem is like the word problem where somebody has something, someone gives him some more, how many does he end up with? Okay, so for example, John has 3 cars. Susie gave John 3 more cars. And then the question would be, how many does he have now? How many does John have now? Okay, so the number showing that would be 3 plus 3 equals, you figure it out, it's 6. You can have different parts of that problem. You can make that problem go 3 different ways. You can have right here, this is a result unknown problem. Okay, and we're going to fill out a sheet in just a minute about this. A result unknown problem. So if the result's unknown, I know the start, I know the change, I don't know the result. You could also change this to where you don't know the start. So John has some cars, Susie gave him 3 more, he ended up with 6 cars. How many did John start off with? You can also have the change unknown. John has 3 cars. Susie gave him more. He now has 6 cars. How many does he? How many did Susie give him? Okay, so you could change the result, the start, or the change. Those are the only other 2 options there. We could also make this a separate action problem, and that's how I turn this problem into a subtraction problem. So separate action would be John has 6 cars or 5 cars or however many. Some got taken away. He gave some away. Now how many does he have? So same thing, but this time we're giving away. Or eating, if we're talking about cookies, taking away, something like that. Okay, so similar to joint action, it's just we're taking away here, so it's a subtraction problem. Okay, so those are all the action problems. Like something is happening, somebody's giving something to somebody or taking away something. We can also do 2 other types of problems, 1 addition, 1 subtraction, and these have no action to them. So the first version is called a part-whole problem. So part-whole problem. This is an addition problem, and there is no action happening on this problem. So for example, if I have a whole set of marbles, okay, so I have a whole set of marbles and there's, I don't know how many are in the whole set. I have 2 parts, 1 red, 1 blue, and you can make a word problem out of that. So for example, John has some marbles. So this is an example. John has some marbles. He has 3 red and 4 blue marbles. How many does he have total? So to do that problem, you're going to add 3 plus 4 gives me 7, so he has 7 total marbles. Notice John didn't give any marbles away. Nobody gave him any marbles. This is just talking about a whole set and 2 parts of the whole set. Okay. So no action happening there. We're just talking about 2 parts of a whole set of something. The last type of problem is called a compare problem. And this is also a no action problem. Okay, so 4th type is a compare problem. This shows subtraction and again, no action happening on this problem. Basically, a compare problem is taking 2 sets and comparing them. So 2 sets that are compared. Two sets that are compared. There we go. So, for example, John has 7 marbles, Susie has 5 marbles. How many more marbles does John have than Susie? So you're comparing 2 sets of something. Okay, so set 1, set 2, how many more? Okay, so now we're going to take each of these problems and write a word problem to show the different ways you can show each type of problem with the result and the change unknown. So what I'd like for you to do, if you haven't already, if you'll print off the problem type, or you can just copy it onto a piece of paper if you wanted to, the add subtract model. It has a bunch of tables on it, or has a table with a bunch of empty boxes on it. If you'll go ahead and stop the video, pause the video, and work on that page and see if you could write a word problem for each type with the result unknown, change unknown, start unknown, and then I'll give you the answers for that. So pause the video here, and here is an example, or here's some examples. It's not the only example. So if we were going to do a join problem, we're talking about Joe. Joe has 5 apples. His mom gives him 3 more apples. So I could do that problem 3 different ways. I could do the result unknown, the change unknown, the start unknown. So the result unknown would be Joe has 5 apples. His mom gave him 3 more. How many does he have? The change unknown, Joe has 5 apples. His mom gave him some more. Now he has 8. How many does mom give him? The start unknown, Joe has some apples. His mom gave him 3 more. Now he has 8. How many did he start with? Okay. For a separate problem, let's do Mary has 6 oranges. She eats 1. Okay, so if I don't know the result, Mary has 6 oranges, she eats 1. How many does she have left? The change unknown would be Mary has 6 oranges. She got hungry and ate some. Now she has 5 left. How many did she eat? So 6 minus how many equals 5? Start unknown. Mary has some oranges. After eating 1, she has 5 left. How many did she start off with? So those are your 2 action problems. Let's talk about the part whole. So let's talk about marbles. Jane has some marbles. 4 are red and 1 are white. So the whole unknown or part unknown, there are 2 options here. The whole unknown, Jane has 4 red, 1 white. How many total marbles does she have? A part unknown, Jane has red and white marbles. She has 4 red and 5 total. So how many are white? Okay, and you could change that one also and tell how many white ones she has. Make him find the red. The last one, the compare. John has 10 apples, James has 4 apples. So if I don't know the difference, John has 10, James has 4. How many more does John have than James? If I don't know the larger quantity here, John has 6 more than James, and James has 4. How many does John have? And then the smaller, if you don't know the smaller one, John has 6 more than James, and John has 10. How many does James have? So, again, you could do any examples on here. You don't have to do marbles and oranges and apples. You can do whatever you want here. Here's just examples of all the different types of problems. So you just need to make sure that you are able to recognize what kind of problem is and what the unknown is in each problem. And then also you need to be able to write your own problem. If I ask you to write a separate action problem or a compare problem with the difference unknown or whatever. Okay. So the last thing we're going to talk about in this video is the developmental stages for children to solve problems like this. Okay. So there are 3 developmental stages. For students to start solving these problems. And the first stage is direct modeling, which is using something they can touch, so using manipulatives. Or you could also draw pictures if you needed to. Okay. So students start off in this stage, and everybody starts off in this stage, and then before they can move to the next stage, they have to master this one. So an example of direct modeling, let's do 2 plus 3. Okay, so 2 plus 3, you would have to put 2 things down. So I have some paper clips right here, so I'm going to do paper clips. So I have 2 paper clips here. If I wanted to add 3 more, how many paper clips do I have total? So here's 3 more paper clips. And so a student this stage would put the 2 down and count 1, 2, and put the 3 down and count 1, 2, 3. So now how many total? 1, 2, 3, 4, 5, probably touching each one each time. Okay. You could also do it without a manipulative. You could do it with a picture. So if I have 2 things, I add 3 things to it, I have a total of 5 things. And this is our set model for addition that we learned last time. Okay, so that's direct modeling is showing, and you can, when you work out your homework and ask to use direct modeling, you can just use a set model to show that. Okay, the next stage, once you get past this stage, would be the counting method. Okay, so the counting method is, if I wanted to add 2 and 3, I don't need to count my 2 to start off with. I can start with 2 and add 3 more to that. Okay, so if I wanted to show 2 plus 3 again equals 5, the counting method would say, this is what I'm thinking, start with 2. So start with 2. Then use your fingers or use whatever to count 3 more. This is actually a huge jump from the one before. Students in kindergarten usually aren't ready to start at this. They're still at the direct modeling stage. And so more than likely, you're going to have students, depending on what grade level you're planning on teaching, but if you're planning on doing early grade levels, part of your work is getting from the direct model to the counting method. Okay, so if I wanted to do 2 plus 3, then on my hand, I would use 3 fingers. This is my little hand, right? I don't want to draw all the 5 fingers here. So I start off with 2 and I count 3, 4, 5. I'll hold up 3 fingers and count. So this would be 3, this would be 4, this would be 5. So that tells me 2 plus 3 equals 5. Does that make sense? Another example, if I wanted to do 5 plus 4, I would hold up 4 fingers. I already have the number 5 in my head. 6, 7, 8, 9. So 5 plus 4 is 9. So starting with one of the numbers and counting up the other number is a huge jump for students. And you have to do lots and lots of modeling to get them to that point. Once they're ready for it, it's this pretty quick, easy transition, but they have to be ready for it. You can also do subtraction with this. You can do subtraction with the direct modeling, which we kind of went over the set model for subtraction. So you can do subtraction with the counting method. So if I want to do 6 minus 4, that means I'm starting with 6. I'm counting down 4 fingers. Okay, so count down 4 fingers. So starting off with 6, I'm going to draw 4 fingers here. So starting off with 6, this would be 5, this would be 4, this would be 3, this would be 2. So 6 minus 4 equals 2. Okay, and with your fingers, start off with 6, 5, 4, 3, 2. Okay, so that is the counting method. So once they've jumped from direct model to counting method, the next jump would be using a number fact to be able to do addition and subtraction. Okay, and this is what we spend the majority of elementary school mastering, is fluency with number facts. Okay, so there are 2 different types of number facts that we're going to talk about. Number facts, excuse me. 2 different types of number facts we're going to talk about. So the first one is numbers that add to 10. Okay, this is a huge thing for them to master, and not saying that they're not going to be successful in the future without this, but it's going to be, they're going to have some struggles if they can't master the numbers that add to 10. So what are numbers that add to 10? 1 and 9, 2 and 8, 3 and 7, 4 and 6, 5 and 5, 6 and 4. Lots of students don't realize 4 and 6 and 6 and 4 are the same thing for a while. 7 and 3, 8 and 2, 9 and 1. Okay, so if they can memorize these number facts to make 10, addition problems and subtraction problems become a lot easier. Okay. The other thing, the other major one is doubles that we focus on. Okay. So doubles, and later on you add doubles plus 1. So doubles, 1 plus 1 is 2. 2 plus 2 is 4. 3 plus 3 is 6. 4 plus 4 is 8. Oh, 4 plus 4 is 8. 5 plus 5 is 10. 6 plus 6 is 12. 7 plus 7 is 14. 8 plus 8 is 16. 9 plus 9 is 18. And 10 plus 10 is 20. Okay, so they use these number facts to solve a problem. So for example, if I wanted to do the problem, let's do 8 plus 7. And we're going to use number facts to solve 8 plus 7. There are 2 ways you can do this. So if I wanted to use numbers that add to 10. So to do 8 plus 7 and using numbers that add to 10, I know 8 plus 2 is 10, right? Because 8 and 2 are numbers that add to 10. 2 is 5 away from 7, so I need to add 5 more to get that whole 7 in there, right? I split 7 up into 2 pieces and 5 pieces. So 8 plus 7 is 15 because I added to 10 and then I added 5 more. Other way to do it is using doubles. This is probably the way that you would have done it, more than likely. If I want to do 8 plus 7, I know 7 plus 7 is 14. And 8 is 1 more than 7. So I need to add 1 more to get 15. Okay. Or you could do doubles. 8 plus 7, you do 8 plus 8. You could also say 8 plus 8 is 16. 8 is 1 more than 7, so I need to subtract 1 to get 15. Okay. So if I gave you a problem, can you tell me what kind of problem it is, and then show the 3 different ways to do it, like the 3 different methods? So for example, let's say Peter has 7 books. His mom gave him 2 more books. How many books does he have now? Okay, so first of all, what kind of problem is this? Is there action happening? Did his mom give him books? Yes, his mom gave him 2 more books. An action happened, so it's either a join or a separate problem. This is a join problem because I'm adding to it. And what's the unknown here? I know the start, I know the change, I don't know the result. So this is a result unknown problem. Okay, so that's the first thing. Second thing, can I show the 3 models to show this? Okay, so can I show direct modeling to show this? So direct modeling is drawing picture. I have 7 books, so I'm going to draw a set of 7 books. 1, 2, 3, 5, 6, 7 books. Mom gave me 2 more, so add 2 to it. So now I have a total of 1, 2, 3, 4, 5, 6, 7, and then add 2 more, which is, I could count at 1, 2, 3, 4, 5, 6, 7, 8, 9 books. Okay, so that's direct modeling for that problem. The counting method for that problem would be, I start off with the number 7 in my head, I count up 2 more fingers. So all I need to draw is 2 fingers. So I start off with 7, count 8, count 9. So 7 plus 2 equals 9. And the thought process here is I think 7, count 2 more to get to 9. And then the last one, if I wanted to use a number fact for this, I probably wouldn't use a double here because 7 is really far away from 2. I wouldn't want to do 7 plus 7 is 14 and then subtract. Instead, I'd probably count to 10 or get to 10. I know 7 plus 3 is 10, but 3 is 1 more than 2, so I need to subtract 1. So 9 would be my answer. Okay. I hope that is helpful. I do have a couple of quick little activities to show you. I've attached these as part of your notes. So these are with dice again. So this was, I love doubles recording sheet. So you have 2 dice or a double die. You just need 2 rolls each time. So you roll 2 numbers, and whatever 2 numbers you roll, you record them. So say I rolled a 3 and a 5 first. That is not a double. So I put 3 plus 5. I add them together to get 8. Okay. Roll again. This time I roll a 6 and a 6. That's a double. So over here I'm going to put 6 plus 6, add them together to get 12, add 12 to 8, get my total here. Okay, so that's just a fun little activity. Which ones are doubles, which ones are not doubles, and you're doing lots of addition in there. Okay, another example is betweeners. So you can have up to 4 players here. I'm sorry, 4 players. You can do 3. You can't really do 2 very well for this, but each player rolls 2 dice, 3 dice, however many you have, whatever type of number you want to do here. If I roll 2 dice, so I roll 2, and I get the number a 2 and a 3. So I'm going to put a number down here. So I rolled a 2 and a 3. The number I would, here I can write on this. So player number 1. Say I roll a 2 and a 3, and I'm going to make the number 32 out of this. Player number 2. Let's say player number 2 rolled a 4 and a 7, and they choose to make the number 7. Oh, I can't. Well, if you have a 10-sided die, you can do a 7. Let's pretend like I have a 10-sided die. Okay, so I'm going to make the number 74 out of this, and player number 3 rolls a 1 and a 2, and they choose to make the number 21 out of it. So then you decide who's the highest, who's the lowest, and who's in the middle, or greatest and least, whatever terminology you want to use. So the greatest number here would be 74, the highest number. The lowest number here would be 21, so L, and then in between would be 32. So you can make whoever you want to win. You can say, let the betweeners win. So 32 would win here. So this helps students to think about, do I want to make 47 or do I want to make 74 out of this? Do I want to make 12 or 21 out of this? So it kind of helps them think about putting numbers together. So that's an example of a game you can play. And then this is a really fun one. You can do it. I have a graph 0 to 18 and 0 to 24, depending on what kind of dice you're using. But, so let's say I roll a number. I have 6-sided dice, so let's say I roll a 2 and a 3. So I add together 2 plus 3 is 5, and I put it in the 5 category. 2 plus 3 is 5. Okay, so I roll again. This time I get a 6 and a 1. 6 plus 1 is 7. 6 plus 1 is 7. Okay. I roll again. This time I get a 6 and a 5. 6 plus 5 is 11. 6 plus 5 is 11. So on and so forth. And you just keep on. If you get another 5, like say I got a 4 and a 1 this time, 4 plus 1 is 5. Okay. And so they can see all the combinations you can use to make this. You can also talk about, can you get 0 rolling dice? No, because you can't have a 0 or a 2 zeros on the dice. Can you get 1 rolling 2 dice? No, because each of them, the lowest they could be is 1. You can see all your combinations here. You could also make them like highlight doubles on here, so on and so forth. So lots of fun things you can do on this. This might be something that after they finish their work, they pull out their dice and do this, or wait on the bus, or waiting on recess, or, you know, something like that. So math happening, they don't realize it, and they're doing lots of addition and seeing lots of different ways to add things. Okay, so for this week, you have a week 4 reflection. And that's over the growth mindset, growth and fixed mindset. So week 4 reflection, you also have a week 4 homework assignment this week. And just to let you know, I'm going to go ahead at some point this week and post the review for your test this week. We're going to go over the review in week 5 though. Okay, and your test will be in week 6. So we will talk more about that in week 5, but I want you to go ahead and have the review to start working on it if you would like to.